Okay, now we're going to start to use the equilibrium constant and its value in a variety of problems. We'll start with this one. So we're going to imagine the process of carbon dioxide gas getting dissolved into some water. And for this process, as written, the equilibrium constant dealing with pressure is 0.034 at 25 degrees Celsius. So this would describe, say, this bottle here that's sealed under about 4 atmospheres pressure. That would be the pressure up here in the headspace. And we want to know if the equilibrium pressure up here is 4 atmospheres, how much carbon dioxide is going to be dissolved in the beverage itself. So that's the question. What's the concentration of dissolved CO2 expected in a sealed beverage with an equilibrium pressure of 4 atmospheres? And then we're going to try it again at 0.0004 atmospheres, which would be the pressure over the fluid after you open the bottle. Okay, well, we can write for this process that Kp, that's going to be the concentration of dissolved CO2 divided by the pressure of CO2, and that's always going to be equal to 0.034 at equilibrium. So we want to know the equilibrium concentration of carbon dioxide. And this is really quite simple, right? I mean, we're given the equilibrium pressure. We're given Kp, so I know this. I can easily solve for this. So if I just multiply both sides of this equation by the pressure of CO2, then that'll cancel this, and this would transform into the pressure of CO2 times Kp. That's going to be the equilibrium concentration of dissolved carbon dioxide. And that's fairly easy to do. So at 4 atmosphere pressure, my concentration of CO2 at equilibrium, that's going to be PCO2, which is 4. We're going to multiply that by Kp, which is 0.034. And that's going to work out to 4 times 0.034, 0.136 molar concentration of CO2 dissolved in the beverage. If we want to know what the concentration would be when we open the bottle, where in the atmosphere, the concentration of CO2 drops dramatically, well, it's just the same thing. But in this case, instead of 4 atmospheres, it's going to be 0.0004 atmospheres times our equilibrium constant, 0.034. And if we run that calculation, 0.0004 times 0.034, we get, wow, 1, 2, 3, 4, 5, 1.36 times 10 to the negative 5th molar CO2. I mean, that's pretty low. That's essentially all of the carbon dioxide escaping from the beverage. And of course, this is why when you open a bottle, you see bubbles form. Let's see if we can get this to happen. So I'm going to release the pressure, and hopefully we start to see bubbles form in the fluid as the carbon dioxide releases. Now it's happening very slowly, but if we wait long enough, remember, equilibrium calculations don't tell you how fast things happen. They just tell you where it's going to head. If I leave this bottle open long enough, it should go flat.